Again, we are going to look at electrolysis of solution. So there is two solutions here, sodium sulfate solution and copper sulfate solution. We are going to look at it today. Okay, so in an electrolytic cell, we have battery, we have wire, we have anode and cathode, and we also have the electrolyte. So the electrolyte, it must contain the ion. Okay, so you have positive and negative ion in the electrolyte. So when you switch on the battery, the electric current will start to flow. So when the electric current starts to flow, the electron coming from the battery, it will go up from the negative side of the battery. So there is electron flowing up here. And this electron will flow to cathode. And this electron will be accepted by the positive ion in the electrolyte. And it receives the electron and it becomes discharged. It loses the positive charge. It will become an atom. Okay, and then the negative ions in the electrolyte, however, will move to the positive anode. And then it will also be discharged. So this negative ion will be discharged by losing one electron, and it becomes no more charge. It becomes an atom. So this electron that has been lost, it come up from this ion. It will come out from this ion and it will go into the wire, and then it will go to the positive side of the battery. So when the electric current flow, there is an electron coming out from the negative side and an electron going into the positive side of the battery. So this is how electric current can flow in the circuit and how electricity produced. Okay, so when you switch on the switch, the electron will come out from the negative side and electron enter in the positive side. So this is how the electron flow and how electricity is produced. So when the electricity is produced, it will make the ion in the electrolyte to discharge. So ion will become atom or ion become molecule. Okay, so let's look at solution. In molten lead-2 bromide last time, in the video, there is only two ions, one positive and one negative ion. There is no other ion. However, in solution, so for example, sodium sulfate solution, you have four ions. So sodium is one positive ion, sulfate is one negative ion. Solution. The word solution tells you that there is water molecule inside. So this water molecule will also produce hydrogen ion and hydroxide ion. So in sodium sulfate, you have sodium ion and hydrogen ion, they are positive ion, and then sulfate ion and hydroxide ion, they are negative ion. So sodium and hydrogen ion, they will move to cathode. Sulfate and hydroxide ion will move to the anode because the charge are opposite. Okay, positive ion attracted by negative cathode, negative ion attracted by positive anode. So we also call the sodium and hydrogen ion, they are moving to the cathode, so they are cation. Sulfate and hydroxide ion, they are anion because they move to anode. Okay, so there are two ions at cathode. Okay, we look at cathode. There are two ions in cathode, but there is only one ion can be discharged. Discharge means lose the charge. Okay, so who is going to discharge? Sodium ion and or hydrogen ion. This one we have to look at the electrochemical series. So these are the electrochemical series for all the cation. So on the top of the series, there are all the ions that are more electropositive. Okay, more electropositive. That means they like to become a positive ion. Moving down the series, for example, silver. Silver is less electropositive. That means they don't like to be a positive ion. So a more electropositive ion, for example, potassium, they are not easily to become atom because they feel very comfortable. They like to become an ion, so they will not become atom easily. Okay, so this is what more electropositive means. Silver ion, however, is the least electropositive in this series. So silver ion is very unhappy to be a positive ion, and it wants to become atom. It will very easily to become atom when there is a charge. So this ion, it will lose the charge. It will discharge more easily. So back to the question. I have to choose between sodium ion and hydrogen ion. Sodium ion is here, hydrogen ion is here. So very obvious, sodium is more electropositive. Hydrogen is less electron positive. So hydrogen ion, it doesn't like to be a positive ion because it's less electropositive. So this hydrogen ion will lose the charge. And it's very easy for hydrogen ion to lose the charge compared to sodium ion. Sodium ion is happily become a positive ion. So for hydrogen ion, he is not so happy. So he will lose the charge. He wants to lose the charge. So we select hydrogen ion to lose the charge. Okay, so hydrogen ion will be selected to be discharged because it's less electropositive. Okay, it's less electropositive. And what it means discharge? It will lose the positive charge. But how it loses the positive charge? The positive charge means that this hydrogen ion is left of one ion. So that's why it's positive. It left of one negative ion. So to lose the charge, he needs to receive an electron, a negative electron. So the electron coming up from the battery, it will move to the cathode and it will be received by this hydrogen ion. So this hydrogen ion, it will receive one electron and become no charge, H. But hydrogen is a non-metal. So non-metal, it cannot exist as atom. Very soon it exists as atom, it will react with another hydrogen and become molecule. Hydrogen H2 molecule, yes. Okay, almost all the non-metal, they will become molecule. So you will see hydrogen gas here. So you will see bubbles around the cathode. That is hydrogen gas. Okay, and we look at anode. Okay, anode, same thing. You have two ions, sulfate ion and hydroxide ion. We look at the electrochemical series. Sulfate ion is here, hydroxide ion is here. So sulfate ion is more electronegative, okay, because these are all a negative ion. So we say that sulfate ion is more electronegative. It's happy to be a negative ion. Hydroxide ion is less electronegative. It's less happy, it don't want to be a negative ion. So hydroxide ion will very easily to lose the charge. Hydroxide ion will be easier to lose the charge, to discharge compared to sulfate ion. So we select hydroxide ion to discharge. Okay, so hydroxide ion will discharge because hydroxide ion is less electronegative. So it's easier for hydroxide ion to discharge compared to sulfate ion. Okay, hydroxide ion. So hydroxide ion, when it loses the how it loses the charge, how it loses the negative charge. This negative here means that it has extra 1 electron. So if it has extra 1 electron, what you need to do is just throw away this electron. Okay, so it will throw away 1 electron. So 1 electron come up. All right. So when 1 electron come up, it becomes H2O, water, and also oxygen gas. So what you will see is also gas bubble, and that is oxygen gas. Okay, just now at the cathode that is hydrogen gas. Now at the anode that is oxygen gas. So you will see gas bubble at both cathode and anode, but actually there are different gases. Okay, so like let's say you imagine you are doing an experiment, you can only see gas bubble. So how do you know that that is hydrogen gas, that is oxygen gas? You can do tests. Okay, you can do a test. Okay, so for oxygen gas, look at here. Oxygen gas, you can do growing wooden sprinter test. This is a growing wooden sprinter test. So when you put this growing wooden sprinter into the oxygen gas, you will hear the growing wooden sprinter will ignite. So the keyword is ignite. That means it will start to grow because oxygen can help it to burn. Hydrogen gas, you use growing wooden you use burning wooden sprinter test. It's already burning with fire. You put it in the hydrogen gas, you will hear a pop sound. Okay, so growing wooden sprinter ignite. For hydrogen gas, burning wooden sprinter, it will pop sound. Okay, so far so good. We look at another example, copper sulfate solution. So same thing, you have copper, you have sulfate ion, copper ion, sulfate ion, solution, hydrogen ion and hydroxide ion. Okay, so again, there will copper ion and hydrogen ion both move to the cathode, and sulfate ion and hydroxide ion move to the anode. Okay, so we are going to choose between copper and hydrogen. Okay, so which one to choose? We look at the electrochemical series. So copper is here. Okay, hydrogen ion is here. Okay, so hydrogen ion is more electropositive because hydrogen ion is on the top of the copper ion. Copper ion is less electropositive. So when you compare these two, which one is less happier to be a positive ion? Copper ion. Copper ion is less happier. So copper ion, it will be easier. It will be easier to discharge. So copper ion will discharge in this case. So I select copper ion. So how copper ion discharge? How a positive ion loses the charge? It will receive electron. It have 2 plus here. That means copper ion is lack of 2 ion. So that's why it's 2 plus. So we give it 2 electron. Okay, sorry, copper ion 2 plus. That means it lack of 2 electron. So we give it back 2 electron so that it can become no charge copper atom. For copper is a metal, so all the metal will remain as atom. So you will see a layer of copper stick on the cathode. Okay, so where this electron come from? Again, from the negative side of the battery. Okay, it will go to the cathode and then it will go to the copper ion, combine with the copper ion and form copper atom, no charge. Okay, and then at the cation, one will be selected to be discharged. Again, we look at the electrochemical series. Hydroxide ion and sulfate ion, same story like just now. So hydrogen ion will be selected to be discharged. Hydroxide ion will be selected. So it will throw away one electron, it becomes water and oxygen gas. So you will see gas bubble, that is oxygen gas. Okay, so let's see how do we explain it in word, in sentence. So copper sulfate solution. So first, when you look at the word copper sulfate solution, you have to write down all the ion like how I did, and then you write down which one is a cation, which one is an anion. Okay, so copper ion and hydrogen ion, they are positive ion, so they will move to cathode, a negative cathode, so they are called a cation. Negative ion, they will move to anode, so they are called an anion, right? Okay, so first you explain cations are hydrogen ion, copper ion, and ion are sulfate ion and hydroxide ion. So this one, it may come up in structure question and ask you to write down what are the cation and ion, and you have to write this yourself. And then you have to explain, sometimes question asks you to explain what happened at the cathode. Okay, so what happened at the cathode? At the cathode, the copper ion will be selected. Okay, the copper ion is selected to be discharged. So these are the keywords. Copper ion is selected to be discharged, and then you have to explain why. Because copper ion is less electropositive. It's less happy to be a positive ion, so it's easier for copper ion to lose the positive charge. So copper ion is less electropositive and hydrogen ion. You just write this keyword and you explain, you already explained why. Because copper is less electropositive, so copper ion will be discharged. And what happened? Solid copper atom produced. Okay, so this is cathode. You don't have to explain how the electron come from. Okay, you don't need to explain that. And normally question don't want you to explain that part. They just want you to explain how it discharged, which one it discharged, and why it is discharged. So take note on this. Take note on this. And then what is produced? So these three things, normally the question will ask. Okay, now anode also the same. You explain hydroxide ion is selected to be discharged, and then explain why, because it's less electronegative. Okay, so the word electropositive, because this is a positive ion. Electronegative, because this is a negative ion. So you cannot say that hydroxide ion is is less electropositive. It doesn't make sense. Hydroxide is a negative ion, so you say that hydroxide ion is less electronegative. And then what is produced? Oxygen gas. So these three things are the most important thing. Okay, you explain which one is selected to be discharged, why, and what is the product, what produced. Okay. So that is this is all about the solution. You have to know, again, you have to know what are the cation, what are the anion, what happened at anode, what happened at cathode, which one is selected to be discharged, which one and also why, and what is produced. So these are the few important things you need to know. You don't have to explain where the electron comes from. You can say that copper ion discharged by Okay, you can explain in even more detail. Copper ion is discharged, is selected to be discharged by accepting by receiving 2 electrons. Okay, by accepting 2 electrons, no problems. If you want to explain it like this. Hydroxide ion is selected to be discharged by donate the electron by donating 1 electron. Okay, no problem. But you don't have to talk about this one. It will be too complicated. But sometimes the question will ask you, label how the electron move. Label how this electron move in the circle. Then you have to draw this arrow, okay, like this. Okay, and then show the direction of the electron movement. Okay, and then this one go up. So from negative to the positive. Okay, the electron is always move from the negative to the positive. Same like any electric circuit. You have a battery. Okay, you have a light bulb. Okay, switch. When you close the switch, the electric current will start to flow. How electric current flow? The electron from the battery will flow to the light bulb and then flow back to the positive side. So the electron will flow from negative side to the positive side. So when it make one round back to the positive side, there is electric current and the light bulb will light up. Okay, so for all the electrolytic cells, okay, this one is summarize everything. The electron coming out from the negative side of the battery, it go to cathode. The ion, the positive ion in the electrolyte, okay, positive ion, it will discharge by combining by accepting this electron, and become discharged. It will be discharged, so no more charge. And what happened to the negative ion in the electrolyte? It will move to the anode. It will also lose the charge by donating the electron, and this electron will go into the wire and go to the positive side of the battery. So this is the whole story. It applies to all the electrolytic cells.